Now, exercise 1101, like I said, this topic is sampling and distributions. So, in statistics, there are 3 ways that you're going to learn that you can take a sample. All right? A random sample, systematic, and stratified sample. So, in statistics, the population refers to the total number of items being studied, whether they are people, kangaroos in a national park, schools, or cars. A census, you would have learnt this in year 8, is a survey of the entire population. So if you have a census, you ask everybody in your population. So if we want a census of the school, we have to ask all the 700 kids in the school. But if a population is too large or too difficult to survey, in other words, if we don't want to run a census, which is to ask everyone, we will just take a sample from the population. Okay? So for example, here at school, we might have 700 kids. We might decide we're just going to ask 60 kids a question, or 100 kids. Now, there are different ways that we can select the people that we want to sample or the items we want to sample. The first one is a random sample. So you need to know these 3. 3 main types of samples. Random sample. In a random sample, each item is equally likely to be chosen from the population. For example, there could be a computer program that randomly selects phone numbers in an opinion survey. You know how sometimes people get called up, ask for opinions on certain matters. Another way of selecting a random sample would be picking names out of a hat, numbers out of a hat. But you know what? Your calculator can do random samples as well, which is what we're going to look at today. In a systematic sample, items are chosen at regular intervals. For example, testing every 10th car on a production line. Or I might, let's say I want 60 people from Bethlehem. I might decide that I'm going to sample let's say I wanted every 1 person from, or 2 people from each homeroom circle. I might decide to sample person number 5 and 10 on the homeroom circle roll, or the first person and the 7th person on the homeroom circle roll. But I would do that in each homeroom. That is systematic. I'm going to choose person number 1, person number 7. Next homeroom, person number 1, person number 7. That's a system that I've got in place. It's just like here I'm choosing every 10th car in the production line. I'm choosing every 50th item on a production line. Or I'm choosing an item every 2 minutes. I'm pulling one off and checking it. All right? Systematic, at regular intervals. The other type of sample is what's called a stratified sample. Now, you may have heard the word stratified. It's like rocks. You know how rocks have layers? All right? Or onions. A random sample is taken from each stratum or layer of the population. Now, let's say in a population, if the population has 70% adults, 30% children, your sample must contain 70% adults, 30% children. So let's say, does that make sense? I can't then, if a population's got 70% adults, 30% children, my sample can't contain 95% children and only 5% adults. That would not be representative of my population. Do you understand? That's what that's saying. How can we select random numbers? Well, your computers, your calculators can select random numbers, okay? So random numbers can be used to select people or items of a sample. For example, a calculator or a spreadsheet can be set up to generate a random number from 1 to 100, and that number can be matched to the name of a person or item. So let's say I've got 100 people's names on a roll, and I want a random sample. I can go to my calculator, I can get 10 numbers or how many ever numbers I want, right? And I'll just show you. So I'm going to get 10 random numbers between 1 and 100. So this is how you do it on your calculator. You press random times 100 plus 1 equals, and then you keep pressing equals repeatedly. So let's try that. So how do I do it? I go random. So where's random? There it is. It's down there. So here's random. It's down here. Random. I think it's this one. Shift. Random. Not sure. All calculators might be different. I'm going times 100 plus 1 equals. There we go. So I've done what they said. Random, which you've got to press shift the dot, times 100 plus 1. Now, look. See how I've got 84.3? Yeah, everyone's going to get different. So I've got 84.3. You have to round down. Always round down. Even if it's 84.9, round down. What you do is always round down, please. Now, if I want another number, I just press equals. Equals gives me 17.1. That's 17 for me. Equals again, 71.7. I have to round down. Because otherwise, if I round that up to 72, I might get 72.1, and I have to round that down to 72. So you always round down. Equals again 27. Even though that's 27.9, I round down. I'm just going to get another 6. I've got 20, 60, 59, 87, 38. Girls, you will get decimals. You have to round them down. You must round them down. I've got 69, 81. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Always round down. So, for example, here are my 10 random numbers. Your 10 will be different. Someone else's 10 will be different. So what I do, I might have a list of 100 people in alphabetical order. I then would go to person number 84 on the list, person number 17, person number 71, person number 27, etc. Always round down. Even if it's 81.9. Round down. Otherwise, you will get duplicate numbers. All right? So, but there is another way of finding random samples. So, another thing you can do is use a table of random numbers, such as the one below. So, for example, to find a random number from 1 to 100, you can choose any starting point you wish. Let's say this person started on row 7, column 2 with this number. So let's say we start with that number, and we want a number between 1 and 100, so you have to read off 2-digit numbers. So for example, 60, can you see? 57, 29, 92, 36. Do you see how we're reading off those numbers? So if I start here, I read off 60, 57, 29, that was 29 from there to there, 92, 36, you tell me what's next, 25, 35, 20, 77, 80, etc. That's how you can use a table of random numbers. Now, I can start wherever I want. Let's say I started over here. There. What's my first number? 04, which is 4, 93, 60, 37, 35. If you want a number between 1 and 100, you'd have to read off 2 digits at a time. You see? If you want a number between 1 and 10, you just read off 1 digit at a time. Okay? So I did some random numbers starting from there. A number between 1 and 100, you choose 2 digits, because 2-digit numbers are less than 100. But you could get, and we will sometimes get, oh, look, if I keep going, look here. 33. What's the next one? 47. 47 again, which you would ignore. 71. 70. The next one's 08, which is just 8. Okay? So you can get numbers between 1 and 10. No. That's why we round down always with those others. So, wait. So, sorry, I've missed this. If you do get 2 zeros, if you happen to read 2 zeros anywhere, that is 100. Okay? So you can get 100 on there. So 08 is 8. So I'm sure there's 1 somewhere. All right? Now, there's 100 over here. Yeah, well, It could be 100 and then 3. Do you get it? So there is 100 in that table. All right? You have to put random times 100 plus 1 is that whatever number you get, you're always rounding it down. If you don't put the plus 1, the highest you might get is 99.9, which rounds down to 99. It means you're never able to select the 100th number. So that's why we've got this plus 1. Because we're rounding each number down, we need our numbers to go up to 100.9 or whatever, so we can round that number to 100. Exercise 1101, what is the best way of collecting data to find the 3 best selling brands of chocolate? Do you really think you're going to conduct a census? No. It's too hard. A survey. It would be a survey. Okay? You would sample or survey part of the population. You would not do a census. It's just too hard. Now, give 2 reasons for choosing a sample. Why would you choose a sample? Why would you only choose to test ask some people rather than everybody? What do you think about time? So a census is time consuming and what else? Expensive. Time consuming, expensive, and it's sometimes impossible really. So a census is time consuming and expensive. A sample is the opposite, isn't it? A sample, I don't know, it's more convenient, I suppose. It's just too hard sometimes to get a census, all right? Now, what is meant by a biased sample? What's meant by a biased sample? Yeah, it's if you favour a particular group within the population. This will happen if your sample is not either random, systematic, or stratified. So bias is where you're favouring a particular group. It's if you're asking too many people from a certain group compared to another group, all right? So this will happen if your sample is not random, systematic, or stratified. Okay, so you can choose one of those, random, systematic, or stratified, but if you just decide you're going to ask the first 5, you know, just the people in a certain homeroom circle, that's biased. All right, that's biased. That is not indicative of the whole school. Okay, now, question 4. Now, you know, sometimes random samples are better, sometimes systematic are better, sometimes stratified is better. All right? So, question 4, which type of random sample? Simple, systematic. Simple just means ordinary random sample. Systematic means asking every 5th person, every 10th person, sampling every 5 minutes. Stratified is percentages. Getting the percentage of the population correct. Percentage of sample matches percentage of population for each age group. For example, for each year group at school. So let's say our biggest year group is year 12. If I want to take a sample of students at Bethlehem, I should have more kids in year 12 being asked than other year groups. It might only be an extra 1 or 2 kids in year 12 compared to other groups. But if year 12 has the biggest amount of students, I should be asking more kids from year 12 than other groups. But it has to be in proportion. All right. Now, if we want to do a random breath test, an RBT, they set up on the road. What do you think they do? Have you seen the way they do it? They choose those 5 cars. Another 10 minutes later, they choose the next 5 cars. They make you all go through. Yeah, or that. But what do they normally do? Do you think that's just at random, systematic, or stratified? It is systematic. They do systematic. What they do is they let the cars go past. 5 minutes later, they'll get the next 7 or 8 cars that come. Then they let the other cars go. 10 minutes later, how long that's taken to test them, they'll take the next 7 or 8 cars. So that is definitely systematic. What about an opinion poll on a favourite movie?
Stratified.
Yeah, probably, because you need to ask certain age groups that attend that movie. Do you know what I mean? So it would have to be, I think it should be stratified. It's not like you're going to go and ask a child something about an MA or an M movie. Like a 5-year-old would not be asked something about that. It's got to be that particular age group that's supposed to see it for a start. All right, so stratified. And taste testing a new brand of soft drink. That's probably a good random. Probably random? No? There may be someone set up in a supermarket getting people just randomly to try a brand of soft drink. All right? Okay, now, question 5. A survey about customer satisfaction is conducted by New Wheels Car Magazine. A sample of 400 car buyers is to be selected from a group of 1,500 Holden buyers, 1,500 Ford buyers, and 1,500 Hyundai buyers, and 1,500 Toyota buyers. Now it says a random sample of 100 buyers from each brand was selected. Is this an example of a simple random sample? Give reasons. So look, let's look at the numbers. There's 1,500 Holden, 1,500 Ford, 1,500 Hyundai, and 1,500 Toyota. 100 people from each brand. I will explain what a simple random sample would be. A simple random sample would be to choose to choose 400 people from the total 6,000 people. How did we get 6,000? The 1,500 times 4 is 6,000. So a simple random sample would be if you chose 400 people from the entire 6,000. We're not doing that. Okay? This is not the case. So this is not the case. So it is not a simple random. What it is it's not a simple random sample. They are actually conducting a stratified sample because they are taking the same percentage from each group. They are taking 100 people from each group of 1,500, from each group of 1,500. But within that group, it is more than likely random. All right? So that bit's stratified, but the next bit is random. The 100 people from each 1,500 group is then random. So this is actually stratified on the first level, random after that. So it's not just simply random. We're going to conduct our own random sample. We've got the eye colours and genders of 30 students here. See? We've got the 30 kids and we give them a number, a student number. Now, what we're going to do, we're just going to see what percentage are male, what percentage are female, what percentage have blue eyes, etc. Just going to help you with one or two of these. What percentage of are male? Let's count how many males. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 are male. So male is 13 out of 30 times 100%. All right, so can someone work that out? What did we get? 40.3 recurring. Now what you need to do is do that. 43.3 recurring. You need to do that for each of the others. If male is 43.3 recurring, female must be the other 17 people out of 30 times 100%. which is 56.6 recurring. Now, you can do blue eyes, brown eyes, grey eyes, hazel eyes, right? You can do those. Now, what I need to do, I'm just going to do one random sample. It says select a sample size, a random sample of size 10 from the population by generating 10 random numbers from 1 to 30. How do I do that? I go random, number 30, no, number. I go random. I'm doing it, from the table of random numbers, sorry. Or you could use a calculator, whatever you like. If we use the table of random numbers, I've got to be careful because anyone over 30 I would disregard. Actually, I'm just going to do one on the calc. So random times 30 plus 1 equals. So I can do that. I go random times 30 plus 1 equals, and I get 9, etc., 21, etc., 24. I'm just going to keep going. 24 again, I ignore. 27, 8, person number 26, person number 24, 23, how many have I got?
There will be a junior and senior SRC meeting.
Different answers. Everyone gets different answers. They're my 10 random people. So now what I need to do is choose these people from my list. So I will choose person 6, 8, 9, 13, 23, 24. Oh, sorry, I've got two 24s. I need to change one of them. I'll make this one 15. You can't have repeats. Okay? So I've chosen 10 random numbers. So what I need to do is circle those numbers on my list. So I'm going to do that now. Number 9, number 21, number 24, number 27, number 8, number 26, 15, 23, 13, and 6. And they're the people I'm going to look at, those 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm going to work out the percentage of those that are male, okay, from my ones. So let me look how many male I've got. 1, 2, 3, 4. Do you see from my list? So from my list, the percentage that are male is 4 out of the 10, which is 40%. You get it? And then I'll look at my list and work out the percentage that have blue eyes. But remember, I still have to do all those answers for up here for the total population. Do you think my 40% result is close to the male of 43%? It's pretty close. Let's look at percentage blue eyes. How many blue have we got? We've got 1, 2, 3. I've got 3 out of 10 with blue eyes in my sample. No, I don't. Yes, I've got 3 out of 10 with blue eyes in my sample. Blue eyes is 3 out of 10 in my sample, which is 30%. I actually haven't worked out blue eyes in the total population, but I'm going to do it now. Okay? So that's in my sample out of the 10 I chose. 3 out of 10 is 30%. You times it by 100. In the entire population, if I work out the percentage with blue eyes, I need to count all of the blue-eyed people. So what have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In the entire population, 11 out of 30 have blue eyes. So the percentage of people that have blue eyes in the entire population is 36.6 recurring percent. My sample shows 30% blue eyes. It's close. All right, a bit off, but it's fairly close. All right? Yeah. So can you see, of course the sample is not perfect, but it's close. All right, now the bigger the sample, the closer your answer to what the actual thing is. And that's how we conduct a random sample. Of random numbers to choose a number between 1 and 30. Anything over 30 I'd have to ignore. So I'm just going to start from here. 99, 37, 82 I've got to ignore. I choose 22. 95 I ignore. 32's out. 79's out. 04 is in. And you just have to keep going till you find 10 numbers under 30. 94, no. 70, 70. 12 would be in. 96 is out. 09 is in. You would just keep using that table of random numbers until you got 10 numbers between 1 and 30. And then you'd use those 10 numbers, choose those 10 people on the list because they're numbered, and do your percentages with that as well.